So here we're going to do section 7.6, natural logarithms. So we found out that log base b of y equals x is the inverse of y equals b to the x, to where the logarithm isolated that exponent, right? Logarithms helped us solve for variables when the variable was in the exponent. All right? In this section, we're going to learn that the inverse of y is equal to e to the x, and e has lots of applications in terms of financing and other types of deeper math concepts as you move into calculus. It gets its own special logarithm. And so what happened was people got tired of writing it as log base e of y is equal to x. It's called natural logarithm, and it's going to look like this. It would be, it'd be ln. So I assume that L is for log and then N is for natural. So we have ln of y is equal to x. Now it's the same thing. So another way you could have written this would be log base e of y is equal to x. But they were using it so often in calculus and various applications that they decided to give it its own log, and it looks like ln. So anytime you see an ln, it is invisible base e. Right? It's its own invisible base of base e. Right? And these come up a whole lot in calculus. They get their own formulas and all sorts of things. Okay. So, the good news is that natural logarithms work just like logarithms because, as stated earlier, they are logarithms. It's just a log with base e, so it's going to follow the exact same principles. So when we're simplifying natural logarithms, same concept as always. So on this one here, we'd see if there's a number out in front, one of the log properties was that it can become the exponent. So this would be the natural log of 15 squared minus natural log of 75. And then we knew that when we had two logs with the same base, which these definitely have the same base, both being natural log, with subtraction can be condensed to one logarithm and division. All right, so we've got here our 15 squared over 75. All right, and then if we calculate this here, we'll get the natural log of 15 squared is 225 divided by 75, and we get 3. All right, so that one simplifies all the way down to natural log of 3. So let's review those properties of logarithms here again real quick. Number out in front comes the exponent. If you've got two logs with the same base and subtraction, you can condense it to 1 with division. All right. All right, so this one here, we got 3 of them, but we'll take them down one piece at a time. They all have the same base. So just remember, if there's 3 things, any of them that are negative are going to roll into the denominator. Any of them that are positive will show up in the numerator. So here we've got the natural log of, here's our fraction. A was with the plus sign, is invisible, but it's there. So A would be in the numerator. This negative here, well, the 2 can go to the b to become b squared, but because of that negative, it's in the denominator of the fraction. And then here with this 1/3 becomes the exponent for c. C is with a plus sign, so it would join in with the numerator. All right, and that's pretty much the way those work. If there's 3 of them, any of them that are negative go to the denominator. Any of them that are positive up there in that numerator. Okay. So let's check out solving natural log equations. Now this is going to be no different than loop and swoop, except the key thing to remember now is that we have a base of e, so it's going to involve some calculator typing activity. Now there's 2 options of how we could do this. I could go ahead and loop and swoop and set it up equal to x minus 3 squared. However, it's going to be more advantageous to go ahead and kind of reverse that property, put the 2 out in front. what that's going to allow me to do is deal with that square, but in a much more manageable fashion. Because if it's out front, I can divide both sides by 2. And that would be easier than doing the loop and swoop from the original standpoint, having to square that out, because then it would turn into a quadratic. We'd have to factor to use quadratic formula, which we'd get the same answer. One of them could have been extraneous. But by using that property, it saves us some time, putting that 2 out in front, and then we can get rid of it with division. So now we are ready here for our loop and swoop. Base of e. So we have e squared is equal to x minus 3. So to finish solving for x there, I'd add 3 onto both sides, and we get e squared plus 3. Oftentimes when you're working with natural logs, you'll be able to leave your answer in form of e, kind of like how we leave square roots in our answer sometimes. Yes, there is a decimal equivalent of this, and we could find that on the calculator, but more often than not, it'll just be left like this, because this would mean more to us than seeing that decimal anyways. We can kind of conceptualize what that would be. And this is checkable. We'd plug it back into the original equation if we wanted to double check it. And let's do that real quick because it kind of shows some neat stuff here. So if I plug in x, which we found to be e squared plus 3, then there's that minus 3, and we're hoping that it equals a 4 here. Let's see why this is. When we simplify the interior here, this is saying we've got the natural log of, I almost forgot my squared here. We'd have the natural log of e squared. And if we go ahead and do this same concept of where I move this 2 out in front and then divide on the other side, we'd get a 2. And remember, natural logs ask, our base to what power gives us this answer? Which obviously e squared gives me the answer of e squared. So that's how I would check this one. I would make sure that it matches up. You could also type in that decimal equivalent on the calculator and make sure that it equals 4. That would work as well. This is kind of how to check it by hand. All right, so let's give this one a try here. All right, well, I see I've got this here. Now, what we have to be careful with is I can't move this 2 out in front in this case because I can only do that if it was to everybody, which it isn't, so we are going to be stuck with that x squared there. I can go ahead and divide both sides by 2 to get rid of that 2, though. So we'd have natural log of 2x squared is equal to 1/2. So that's as far as we can take it. We are now ready to do our loop and swoop to where we've got e to the 1/2 power is equal to 2x squared. Now to solve this one, yes, there's e over here, which makes people kind of freak out sometimes, but just focus on solving for x. We divide both sides by 2. So I'd have e to the 1/2 power divided by 2 is equal to x squared. And then we'd square root both sides, which would leave us our answer. And we have to check to see if one of these is extraneous or not. But plus or minus e to the 1/2 power over 2. All right, and I'll show us how to check this one on the calculator. So solving exponential equations where x is up in the exponent, which means we're going to need to do some drop, log, and roll. Since e's involved, though, we're going to be doing some drop natural log and roll and see what we get out of that. Now, it's just like solving a normal equation. So first thing is going to be getting rid of our 2 there. It's equal to a 14. All right, then we want to divide both sides by 4. So trying to get this into position to where we can do a drop, natural log, and roll. So we get a 7 over 2 here, if I simplify that. All right, so I'm going to drop, and I'll write that e in so that we can see it. Roll these guys is equal to 2x. And then we just finish off by dividing both sides by 2. So there's our x. Our x here would equal the natural log, I don't need to write in e now, of 7 over 2. And then whatever that is, divided by 2. And this would be an easy calculator check here. All right, so trying to solve here. We want to get ready for drop, natural log, and roll. We got to clear stuff up to make some space. So we have e to the x over 9 is equal to a 14. This is now ready for a drop, well, a natural log, and roll. To where there's our base e. 14 swaps with the x over 9. So then to finish off here, we just simply multiply both sides by 9. All right, and when we do this, we get 9 natural log of 14. What's it doing? Oh. Natural log of 14 is equal to x.